All right, guys. I think it is about 11 o'clock, so we will go ahead and get started. Welcome back from the coffee break, most important break of the morning, I think. We're going to talk a little bit about OpenStack today and how it's changed over the past several years and where we think it's going next. So the year was 2010, right? Rackspace and NASA had just announced this new cloud operating system called OpenStack. And anybody who's been to these summits before knows that things move pretty quickly from there. Right? Over the next few years, the summits kind of exploded. We ran out of space in venues. We crushed the conference Wi-Fi and started having to bring in Wi-Fi externally. A lot of code went in, a lot of new projects were spun up, and a lot of deployments started going live in production. So why was that the right moment for OpenStack, right? So 2010 was kind of an interesting time. A lot of stuff was going on both in the industry and in sort of the general economy. And it's not like OpenStack was the only thing out there in 2010, right? There were a lot of other clouds out there, and many of them still are out there, right? So it's kind of interesting to look back and think, well, what propelled OpenStack? What got us to where we are today? And then look at what's going on now and see where we're going next. So my name is Mark Voelker. I'm the Chief OpenStack Architect at VMware. So in the community, I'm also the co-chair of the interoperability work group. I'm a ATC and an AUC, former member of the Puppet OpenStack core developer group. I founded a meetup group in my hometown in Raleigh-Durham, North Carolina. And I've been a member of the foundation pretty much since a couple hours after they opened the registration website. I've been doing OpenStack since roughly 2011, and unfortunately you're going to see a lot of superheroes in the slides today. I'm not one of them. I have no special powers at all other than the ability to eat a lot of donuts. So back in 2010, we'd already kind of figured out that this new cloud thing was actually pretty powerful and pretty attractive and pretty important, and everybody could see that this is where they wanted to be, right? Also, in that world, we had a whole lot of these things called servers. And most of us were pretty well on our way on the journey to virtualize those servers as well. So Gartner back in 2009 wrote that by the end of 2012, they expected about half of the workloads in data centers to be virtualized, right? And that was up from just 16% 3 years earlier, right? So most people were pretty well on their path to virtualizing a lot of workloads in their data centers. And it wasn't just the big guys anymore either. They also said that by the end of 2010, enterprises with just 100 to 1,000 people in their organizations would have a higher penetration of virtual machines deployed than the global 5,000, right? The global 500. So this was now a thing that was going on for everybody. So virtualization had a lot of stuff that came with it as well. There were changes to storage. There were changes to the way we did networking. There were a lot of advancements that came with it. And that had all proven pretty powerful. That's why we saw that big growth, that big steep curve for virtualization in the data centers. At the same time, we had public cloud services being launched as well. And everybody could see that that was kind of another evolution, another way to do things that sort of built on that previous virtualization technology. Now, for those of us that had a lot of servers in our data center and were pretty well on the way to virtualizing them, we had new runbooks in place for how we operated. We had new monitoring tools. We had new storage arrays. We had all these great things in our data centers. If we could turn those into a cloud and not just sort of chuck all those existing investments out the window, that sounded like it made a whole lot of sense. So this is the mood that we were in 2010 when OpenStack was announced, right? And before anybody starts thinking about sunk cost fallacies, just ask yourself if you'd buy a new car every time a model with a slightly newer feature came out. Now, that's one analogy, but reality is most organizations don't have a car, they have a whole fleet of them. So imagine if you're a rental car company. How fast do you want to turn over your entire fleet of cars? Not very, right? Once you've made those investments, you want to keep them around and get as much mileage as you can out of them before you're ready to turn them over to the next thing, right? So this is the mood we're in 2010. And at the same time, we had this new thing called DevOps hitting the scene, right? DevOps was the word. And there were a bunch of new tools out there that were helping with the DevOps movement as well. Configuration management tools like Puppet and Chef had hit the scene. And these were helping us to go faster than ever. We were knocking down all these silos. We had all these new tools. We had infrastructure as code. And this was a big deal for us. If anybody's been around OpenStack for quite some time, you probably remember very early on Mark Collier standing up in front of the keynote stage and saying, if you have fast, you can make your own good and you can make your own cheap. And when we talked to some of the customers on stage in those keynotes, they would say things like, I want fast, fast, and fast with a side of fast. So this is the mood that we were in the early 2010s, right? So the other thing that happened, so now that we had virtualization in the data centers, we had clouds available, we had a lot of new storage technologies. All of a sudden, we were pooling resources in data centers, and our CapEx budgets, they could stretch a lot further, right? Virtualization never would have taken off if it was actually more expensive than just buying a lot of servers, right? So CapEx budgets were now going further than ever. And now everyone kind of turned their focus to the other side of the spectrum. Now everybody wants a crowd of talented developers, because we all know that software is starting to eat the world, right? And developers are pretty plentiful. It turns out software development is a skill that you can get started in pretty quickly, right? And we had a whole cadre of new developers all over the world. Now, developers were also, at this time, increasingly training with kind of a new weapon in their arsenal, right? Open source has been around for a long time at this point, but in 2010, this is an era where it is well established in the data center. Every data center had Linux in it at this point. Every data center had Apache in it at this point, right? LAMP stacks, very, very common at this point. But there were still a lot of hard things in there, right? Raise your hand if you've ever written a perfect Paxos implementation. Yeah, me neither. So, there's still a lot of hard problems to be solved, but we have actually got a lot of tools, and we've actually learned to work as an industry together through the open source community to solve some of those problems. So this also becomes an interesting thing that propels OpenStack forward. So all these changes, right? It turns out, even with all those great new tools, technology transitions like the step from physical to virtual and the step from virtual to cloud can be a little tricky, right? And also when you throw DevOps in there, right? Now we're talking not just new technology, we're actually talking organizational change in organizations, right? And that can be pretty tough. So it turns out this whole rent versus buy concept, where departments are pooling together resources and also dollars, that's actually a pretty big change in how businesses operated. 0% of CFOs that I talked to in 2010 thought it was a great idea to just give everybody credit cards and hope that they didn't spend too much money on their infrastructure rather than giving them a budget, right? And as we started adapting all these new technologies, there are things that had to change, right? The way that you do virtualization, you've got a whole new set of tools, and that means probably the way you handle things day to day, the way you monitor things, the way you do backups, the way you do recoveries, the way you plan disaster recovery, the way you plan resiliency in your infrastructure, all those things change, right? And people had to pick up new technical skills too. So dismantling silos can sometimes lead to a lot of friction, right? So we have people trying to learn new stuff, and we have organizations shifting roles around, and it's kind of uncomfortable for a while when we make those transitions. And on top of that, developers that we just talked about, well, turns out developers tend to specialize, right? How many people in here write 6 languages every day? Yeah, me neither, maybe one. So I write a little bit of Bash, I write a little bit of Python, I write a little bit of Go, but I spend most of my time in 1 or 2 languages, right? And I tend to look at 1 or 2 types of software that I'm writing, right? I'm an infrastructure guy, so I write infrastructure software, right? I'm not very good when you put me in front of a terminal and ask me to write a web user interface. There are probably some people in this room who've lived through some of my web interfaces, and I'm sorry. It's bad. And this other notion was, we all knew at this point in 2010, software is eating the world, right? That's actually not a business plan, as it turns out. And a lot of people that thought software is eating the world as a business plan aren't doing so well today. So, like I say, a lot of friction, right? So here's the thing. Whenever there's big major technology transitions like this, the way you win is rarely about just picking up the new thing, right? That's chasing shiny objects. The way you win and the way you get success is making the right transition to those new models. It's the transition itself that's important, not so much the end state, right? Managing those transitions is what makes companies successful. And we had all these awesome tools, right? In 2006, in the early 2010s, we had all kinds of good stuff coming out. We had SDN becoming a big thing, right? The ONF was founded in 2011, following on the success of OpenFlow. And we had VXLAN and NVGRE published in 2012, which are now kind of everyday standards. Big data was out there. This had kind of reached critical mass in a lot of data centers. I was actually doing a lot of data center work with big data back in those days. And we had sort of second generation technologies there too coming up. Spark came around in around 2014 or so. Even in the distributed systems world, now that we were moving software horizontally rather than scaling it vertically, Zookeeper had been around since 1999-ish in stable form. And just 5 years later, we had Raft, right? A whole new consensus algorithm that was quite a bit simpler than Zab or Paxos before it. And in the cloud space, we had EC2 became generally available in about 2008. Azure was commercially available in 2010. Cloud Foundry this whole PaaS thing that you could run in your data center came around in 2011. So a lot of new stuff coming out, right? And this fundamentally changed data centers. All of a sudden, everybody's worried about east-west traffic, not so much getting in and out of the data center, but what's going on inside the data center. Because remember, we're packing those data centers denser than we ever have before. And when we pack them that densely, we've actually got multi-tenancy now as well. So we have accounting and engineering side by side, and in some cases, we have Coke and Pepsi side by side as well, right? So a lot of good new stuff. And I think that's part of what propelled OpenStack forward. So OpenStack gave us a way to incorporate both the new stuff, all the new shiny stuff. We had the new multi-tenancy, we had the new API-driven infrastructure, we had a whole new ecosystem of tools. And it allowed us to incorporate all that new stuff with all the existing stuff that we knew how to operate, that we knew how to monitor, that we knew how to manage, right? I didn't have to give up the storage array that I bought last year. I could plug that into OpenStack, right? And still get the benefits of cloud and use my existing investments as well. So we got to use the familiar things, and we also got to use the new shiny stuff too. That integration engine is what helped a lot of people who kind of consider themselves the mere mortals of IT get to the cloud space, right? So that integration engine was super, super important. All right, so Mark, you work for VMware. What does VMware care about cloud, right? You guys were doing pretty well in 2010, weren't you? Well, it turns out, VMware is basically a software infrastructure company. That means catching those transitions that I just talked about is pretty much what we do, right? We always are trying to innovate ourselves out of a job. And this is true for most software companies, right? So in terms of OpenStack, it turns out that this is very complementary to the things that we were doing at the time. When you look at the fundamental building blocks in OpenStack, you had virtualization, you had storage, you had networking, software-defined in many cases. This is bread and butter stuff for us, right? This is all big initiatives in our company at the same time. We had a pretty strong hypervisor at that point. We had a huge ecosystem of storage vendors, and we had our own VMware vSAN as well. In the networking space, NSX is one of the big early success stories, both in the ESDN space generally and in OpenStack. And if you just wanted the basics, we still had the good old DVS stuff that people have been operating for years, right? And then we had management, we had billing, we had other stuff that you could put on top to help you manage all this stuff. And people have been using that for a while. So again, they could go to cloud and still keep using a lot of the stuff that they'd already invested in and that they knew how to use, right? So this made total sense for us to get involved in OpenStack. And again, this is how we help people make transitions, right? We give them a path to something better without making them leave everything else behind. So OpenStack is what helped us integrate all that stuff together. It also helped us discover that we could do things that we didn't know we could do before. So we've all seen kind of the new use cases coming out of OpenStack. That's pretty important too. We could all see that there was a lot of new potential here, right? So add all that up. We want fast, we like developers, we want smooth transitions as we make these changes in our technology, and open source turns out to be really good. So you add all that together, what do you have? Open source cloud helps developers go fast, and organizations make smooth transitions. That's what set the stage for OpenStack's growth in 2010. All right, so that's how we got here. So let's talk about what's happening next. So in the past year, I've done a lot of traveling with OpenStack. I think I've logged about 170,000 miles. I counted up my frequent flyer miles the other night. It's getting a little insane. I've been to 4 continents this year. And I've been talking to a lot of people about OpenStack. Every single one of those trips pretty much was related to OpenStack. So there's a lot of use cases out there, right? We work with a lot of different customers. But there are kind of 2 use cases that I see right now picking up more steam faster than almost any other 2 use cases. First, you got IaaS supporting container orchestration systems. And let's be honest, folks, a lot of that is Kubernetes, right? We all have, how many people here have been to a Kubernetes talk since they got here? Yeah, a pretty fair number of you, right? Kubernetes is pretty popular. There's also others out there. Mesos is out there. We have PaaS systems as well, like Cloud Foundry are quite a popular use case as well that I've been talking with folks about. But container orchestration systems on top of OpenStack are a pretty big topic right now. The other one are telco NFV applications, right? So this is another huge growth area for OpenStack. If you look at some of the new members of the OpenStack Foundation, corporate members over the past year or so, you'll see a whole lot of folks in the telco space. In fact, if you walk around here, as many Kubernetes talks as you see, you'll probably see just as many telco NFV talks, right? So these are pretty big growth areas for OpenStack. Now, what's important to note here is that there's a lot of other use cases. Those are just the 2 ones that I see growing faster than almost anything else right now. But there's a lot of sort of more traditional ones growing as well. So for example, we've seen a lot of interest from the financial services space, the e-commerce space, transaction processing. Those are all things that are still going strong here. But if you had to pick two kind of new growth areas for OpenStack, those are my two. So changes are being made throughout OpenStack as a direct result of those two use cases. And I think this is super exciting. Why? Well, so OpenStack is now much more mature and widely adopted than it was a few years ago, right? So when I started running OpenStack in my lab in 2010, boy, was it a mess. I don't think I ever managed to successfully upgrade from Bear to Cactus or even Cactus to Diablo, right? So I pretty much threw those labs away and started over every time. And it was tough operating things. Nowadays, I spin up clouds like before lunch. I spun up 3 this morning before this talk, as a matter of fact, trying to iron out some things. So it's much faster to deploy, it's much more stable, it's much more secure, and it's much more upgradable. So over time, as we've kind of hardened the infrastructure itself, we've also made it a lot more flexible and a lot more powerful. So there's a lot of new tools out in that ecosystem, right? So what I consider to be a very natural and encouraging thing is actually happening right now, which is we are now seeing OpenStack specializing to address those new use cases. And we're not leaving the old ones behind when we do it. So what do I mean by that? I have a theorem. Given time, pretty much every sufficiently good and flexible platform out there on the market trends towards specialization, right? So what's the key example of that? How about Linux? So Linux is that thing that runs in your servers in your data center that we're all familiar with. It's also on your phone. It's in the seatback entertainment unit on the plane on the ride home. It's powering nuclear submarines. It's in my router at home. And it's in the factory robots that built my car. So there's a whole lot of different use cases for Linux. All those Linuxes don't look exactly the same. So there are things that have been added or removed to those Linuxes for those specific use cases. But at the end of the day, they're all still Linux, right? We're now seeing the same thing happen in OpenStack. So when we look at what OpenStack needs to do going forward, I think the specialization that we're starting to see now is actually super healthy for this ecosystem. I think it's a great thing. In fact, I would say if you're going to specialize, don't do it halfway, right? If you're Batman putting on a new suit of armor for a special use case because you got to go fight Superman, you don't just want a new helmet, right? A new helmet's not going to do you much good. You want a whole new suit. And that means that we need the entire ecosystem of OpenStack involved, right? So what kind of changes are we talking about here that I talk about being a direct result of some of these new use cases, right? So, well, there's a couple different buckets, right? So there's things going on in OpenStack code itself. We've extended EPA support over the years, right? So we have things like NUMA topology filters. We have CPU pinning, right? We have VLAN-aware VMs. For scale, we have Cells v2, which is finally ready for multi-cells, hopefully. We have a whole new API in Nova called the Placement API. We have all these things that are kind of going into the OpenStack code itself, right? There's also a lot of stuff that the OpenStack Foundation has been doing. And this is actually pretty important. The governance structure that OpenStack has been pretty influential in a lot of the initiatives that have come out since then. So you heard Mark Collier and Jonathan Bryce talk a lot about composable infrastructure and improved support for standalone services. So I saw a stat at the board meeting the other day. Usage of Ironic in 6 months has gone from like 16% to like 40%. So big growth for Ironic. What's driving that? Well, in a lot of cases, it's containers. People want to try to run containers on bare metal, right? In a lot of cases, they want to use pieces of OpenStack infrastructure standalone so they can run those containers. Maybe I just want to use Keystone for authentication. Maybe I just want to use Cinder to plumb persistent volumes into Kubernetes, right? So those are pretty important. We're also, with my co-chair of the interoperability workgroup hat on, we're also working on interoperability programs for these use cases. So right now, we're in the process of developing something that we might think of as an OpenStack badge for NFV. NFV-ready OpenStack, if you will, right? So a set of tests that vendors can run through and guarantee some level of interoperability for the NFV use case. So maybe those tests include things like CPU pinning. Maybe they include things like SRIOB. We'll see. We're working on that right now. We're actually spinning up whole new conferences, right? So how many people went to the Open Dev conference in San Francisco? Anybody? Nobody in here. I know you did. So we've actually got new conferences in the OpenStack ecosystem just focusing on a couple of these new and emerging use cases. And we've got a growing list of SIGs and cross-participation in a lot of the adjacent communities. I know folks in my own company that are working both on OpenStack and on things like ONAP, right? And that are doing things with Kubernetes and things in the OP NFE community as well. And then the third bucket is kind of the vendor ecosystem, right? So as these telcos, for example, have come up and started being a more and more important use case, they have some interesting constraints and some interesting things that they want. And some of those are things that projects themselves don't necessarily deliver, but in a lot of cases, it's how things are packaged up and deployed. So you need deployment options that range from fairly large and able to handle a lot of stuff and very highly available, all the way down to very small, light footprints, right? You need migration of existing workloads. They want to take the stuff they're already running, maybe in a virtualized environment, maybe sometimes even in a bare metal environment, and migrate that into their OpenStack clouds. They want N+2 upgrades, so they don't want to upgrade every 6 months, right? In fact, some of them don't want to upgrade every year. Some of them want very long support cycles for this stuff. Again, not really something the community is providing at this point, but something that is coming out of the vendor ecosystem. And they want things like hitless upgrades as well. So I don't want my data path to be interrupted, and I don't want my virtual network functions to be interrupted when I decide it's time to go from, let's say, Mitaka to Okata, right? I want to harp on that one a little bit because it's kind of a thing for me, so that we've been doing for a while. I'll talk a little bit about how we do upgrades. And I think this is kind of becoming a trend in a lot of the Kubernetes space as well. So the way we've been doing upgrades for about 3 years now with VMware Integrated OpenStack is what we call a blue-green upgrade pattern. The basic idea is I have a control plane, my Mitaka-based control plane, and that all sits behind a load balancer, right, like any good highly available system. Basically what happens is we'll bring up a second control plane running the new code, side by side with the old one on a new set of VMs. Our control plane is entirely virtualized, right? You can do this with containers as well. You can even do it with bare metal if you're really risky. So we bring up the new control plane, we plumb it into the load balancer, and we do some state synchronization between the two. This is where we bring databases over, we run migrations, all that good stuff, and get things synced up between the two. Once we're done with that, we drop the connection to the old control plane, and we're all done. So now we're running this new Okata control plane. Should we need to roll back, we could, right? Because the Okata control plane is still there. And if not, we're done with it and we can drop it. Throughout that entire process, we have a zero downtime on the data plane. So that's pretty awesome, right? And it gives us a chance to do very fast rollback. We can test things before we actually flip that switch and do the final migration, right? Since we're actually bringing up a whole second control plane, we don't have to worry about N+1 migration. We can actually do N+2 or even theoretically more, right? And all the code that goes behind that, basically when we bring up that second control plane, it's just another install, right? So we get to reuse the exact same code path that we did for the initial install, which makes things a lot simpler. So as an OpenStack community, we've still got a lot of work to do here. So there's all the time new requests coming out of the telco space and out of the container space as well. I don't know how long we've been talking about service chaining now. It's been certainly since at least 2013-ish, I think, probably longer. Everybody wants more scale, but they want it in different directions now. We're now asking, in a lot of cases, we're seeing the telcos ask us to bring the deployment down to a very, very small footprint. In some cases, it's actually going onto a single box that somebody's going to put on a customer premises, right? Obviously, there's still the big use cases as well, and that's why we have things like Celis v2 coming in Nova. Maturation of new features. Celis v2 has been in the work for a while, so it's maybe a good example. We now have all OpenStack deployments are at least a cell of one, and we finally in Pike had the ability to do more than one cell. Easier composition of infrastructure. Again, you've heard Mark Collier and Jonathan Bryce and the foundation talk about this quite a lot, and it's kind of a big thing for us. The vertical interrupt programs, on and on and on, right? So there's lots of work to do. The good news is we've got a lot of friends in this space too. And OpenStack's a lot more powerful, I find, with its friends, right? I don't know how many customers I've talked with that are deploying Kubernetes on top of OpenStack. And I've worked with a lot of folks in the NFE community as well, in ONAP and OP NFE, that are also riding on top of OpenStack, right? So we have SIGs that help bring those communities together. We have meetings. We have all those communities are actually launching programs that are very similar to the OpenStack-powered interoperability programs. So that's sort of a defined test suite that says, yes, this is going to work, right? So one last thing we should talk about is the money question, because this is one that comes up a lot when people think about transitions in the OpenStack ecosystem. So there's a kind of a saying that engineering is science mostly, and a little bit of art, and a little bit of dollar signs. If you're focused on cutting costs and that's your reason for going to cloud, don't do it. That's the wrong answer, right? It's the wrong reason to do open source too, by the way. Focus on delivering value instead. That's really where we want to be focused. That's how businesses succeed. It's not all about CapEx. And again, it's about getting those transitions right. And if you're worried about changes in the ecosystem, you may have seen some companies become less involved or more involved. You've seen some of the startups go out of business or get acquired. There's a lot of shift in these ecosystems as these use cases change, right? Don't worry about that either. I think that is perfectly healthy. It is quite natural that if we're expanding into new spaces, we're going to see new players, right? A good ecosystem, I think, is one where bets are made. Sometimes those bets don't work out, right? More than often, they do. And we're seeing a lot of healthy companies in the space, especially with those new use cases. And there are ecosystems where this doesn't happen all the time. So if you look even further out, there's a lot of new stuff on the horizon that we haven't even talked about yet. There's stuff like SD-WAN. My company actually just made a big acquisition, and we bought an SD-WAN company, so I'm looking forward to that. There's stuff like unikernels, there's machine learning. We're seeing a lot of new security stuff. And at the same time as we're kind of adapting to all those changes coming forward, there's a few things that we don't want to let go of. We want to keep the core stable, we want to keep the options composable, and we want to remember that flexibility is key going forward for OpenStack. All right, I'm just about out of time, so that is all I've got today. And I will be happy to take any questions if you've got a minute or two. All right, thanks for coming.